Good evening, folks. Thank you for joining us this late. I know it's late for some of you. And it's amazing seeing, what was it, 50, 56 people in the chat right now. It really goes to show that a little pandemic can't get in the way of learning, mostly from one another and with each other, and seeing two really good presentations. It's nice seeing the community's interest and depth of research that you're taking in the products that HashiCorp makes. So for tonight, Rob and I would like to show you a way to work with secure data in Terraform without being exposed to the actual secrets. And what we're showing you is part best practices, part not. This is mostly secretless Terraform, but to be able to show you what we're doing, some secrets will be shown on screen. We've got code for you to look at later, and that is filled with comments where we indicate which parts you should not use. That's on purpose. This is learning with each other. So go through the code later, find the outputs that we have in there, find the other stuff that we said to not use, remove it, and you've actually got a best practice set up. My name is Kerim Satirli. I'm a developer advocate at HashiCorp, where I focus on Terraform. And if you have any questions, either after the presentation or at any other point, or you just want to talk Terraform, baking cakes, Great British Bake Off is back on, and whiskey, let me know. And with that, Rob.
Thank you. So as Kerim said, I'm Rob, also known as DevOps Rob. I'm also a senior developer advocate at HashiCorp. I primarily focus on security, specifically Vault. I'm also on Twitter. If my sous chef will just change that, thank you. So yeah, be sure to follow me on Twitter. I do post a lot of content about HashiCorp products, about the future of where we're going with a lot of these products and how we can make things better. So definitely give us a follow there. So let's move on. So I'm going to give you a quick high-level agenda for today. So the first thing we're going to do is we're going to look at how to add secrets to Vault. And then when we covered that, we'll look at how we can then consume those secrets with Terraform. There's obviously a lot more involved than that, but after we've done that, we'll take some questions from the audience and discuss things in a bit more detail. Now, as Kerim mentioned earlier on, we have demo code here, but we also have a GitHub repository with all the code there, which we're going to share with you later on. So feel free to delve into that and try things out. And you have our Twitters, so if you have any questions, ask us or raise an issue on the repo, whatever's easiest for you. And with that said, let's kick off adding secrets to HashiCorp Vault. So if you haven't heard of Vault before, I'll just quickly introduce it to you. So Vault is a secrets management platform. And it integrates well with many things, including infrastructure as code workflows. In this case, specifically, we're talking about Terraform. So what I'm going to show you today is how we can use static secrets to protect our provisioning secrets using Vault. We can also use dynamic secrets to further increase your security, but I don't want to go too much into that because we don't have too much time. So what I'll do is I'll talk more about dynamic secrets at a future DevOps Oxford meetup. So for the first part, what I want to show you is how to add the secrets to Vault using Terraform. So for this to work, we're going to switch to our Vault installation and make some changes. So here we have the UI for Vault. So the secrets engine that we're going to enable for this is the key value, or we call it KV for short. And with that, we can think of it as sort of secrets engines are the part of Vault that actually manage the secrets for you. So it's either going to be storing secrets or it's going to be provisioning secrets. So in this case, we have a key value store. So it's primarily for secret storage. Right? It's going to do all of that encrypted. And when you need to retrieve that, it will decrypt it for you. There are many other secrets engines out there, but for many of you, I'm going to make an assumption that it's probably the first time you've seen Vault. So this is the easiest one to introduce you to, and it plays really nicely with Terraform. So we'll start with this one here. But like I say, it supports secrets engines for pretty much all the major clouds and other services as well. So definitely check that out. We have loads of documentation online that shows you the width of what we do support there. I should also point out that everything in Vault is path-based. So you can see what we're doing is we are enabling the KV secrets engine at this path secret. We could easily enable it at a different path. It could be called DevOps Rob if we wanted. And the reason why we do that is because it's fully backed by the API. So you just think about a URL, and URLs are always path-based. So yeah, that's kind of all we need to know for that. So now we have that configured. We can see that this is the browser of Vault. We also have the Terraform provider, so we could have done this with Terraform. And also we have full API support. It's very mature. We have full documentation for that. We even have a Swagger UI where you can interact with it and try different API commands out. But just for the ease of this presentation, we're just using the UI just to show you that, but there's full support for other methods as well. So here we have the secrets engine configured, but as you can see, we have no secrets in it yet, which is fine. So what we'll do next is we're going to go ahead and we're going to add some secrets to that. So let's switch to our terminal, and we're going to set up the environment. So if you've used Terraform before, you're likely used to setting up provider details within your code. So for example, in AWS, you might be setting up things like your access key and your secret ID, the different pairings there. With Vault, we don't really want to be doing that. You can do it, but it's not the recommended way of doing things. What we'd prefer you to do is to configure some environment variables so that you can literally just declare your provider and leave it blank. So with that, what we're doing is we're just exporting this environment variable here with our local Vault instance. So with that done, now we're going to check the status of Vault. And what we can see here is we have some output from Vault, and it's showing that Vault is initialized and it is not sealed. So let's talk a little bit about that. Initializing is the process involved of generating a root token and unseal keys. So when you initialize it, it will give you that root token that enables you to configure Vault and also gives you the ability to unseal Vault. Now, that brings the question about what is sealing. So sealing is a protective mechanism that prevents access to the Vault. So there are a number of scenarios where this is useful. So it's quite useful in situations where you've identified there's a breach for your Vault and you just want to seal things up and figure out exactly what's going on. By default, when you first start up Vault, it will start up in a sealed state. So the unseal keys that you get when you initialize Vault is how you're going to unseal that. So this is the final step to actually set up our environment. So next we want to log into Vault. So we can do that via the command line. So we would just literally type in Vault login in the CLI. And then it will ask us to input our token. So in this case, because we're just configuring Vault from the beginning, this is what the root token is designed for. So you can use the root token. Once you've got your Vault configured, you probably shouldn't be using the root token. You want to have something that's a lot less privileged than a root token there. So you would just literally input your token here and hit enter. And there we go. Vault is now accessible to the machine. And I can carry out any of the operations that my token allows. In this case, because we're setting it up, we're using root, so that's pretty fine. So let's switch to our editor and have a look at some code.
Thanks, Rob. So let's start by defining a provider. And in this case, the Vault provider, as Rob mentioned, we've got all our configuration in the environment variables rather than committing anything. Think of it as defense in depth. So we're not going to put any data into our Terraform files, not even the Vault host name. Instead, we're pulling everything from the environment. So Vault provider set up. We can already see in Vault status that we're able to log in. So we'll start by generating some random data. And in our case, we're using the random password resource to generate a string of 16 characters. And we're skipping special characters. We'll get to that in the later part of the presentation as to the why. But the important part here is we're inputting a password into Vault. And by using the random password resource, we actually have no knowledge of what we're generating. Of course, because this is a show and tell, we actually do output what those variables are. But again, if you look at the code later on, it will tell you what not to do. So because the content of the random password has to end up in Vault, we also need to JSON encode the string in a very specific format. And JSON encode is part of a collection of Terraform functions, but it's certainly not the only one. In general, if you need to manipulate data, Terraform will have a function for it available. No matter if it's CSV encoding or decoding, XML, JSON, what have you. Mark mentioned this before. Functions heavily expanded over the past few years. So definitely check them out. So moving on, here we're writing a secret that was randomly generated. And the benefit here is that I, as an operator, won't have to worry about thinking of a password that meets my complexity requirements and be memorable. Terraform takes care of the complexity for you. I don't need to remember it. I don't actually know it. It's my preferred way because then I can forget it. And so let's just make sure we can actually apply this plan. If you used Terraform before, you know the Terraform plan command. I like doing it with the out argument because that gives me access to an execution plan that I can run. So we're going to do that. And we can see that we're provisioning a total of 1 resource. It's amazingly simple. It's my favorite kind of demo. And when we do apply, should take a few seconds. Keep in mind our Vault instance is local, which means all of these operations are super fast. But in general, we're only talking network latency and not much more. So with that, I'm actually showing you the output here. And if you look at the bottom, this is our randomly generated password. Our CISO is super happy because it has all the complexity in there. It's not a very good CISO because we don't have any special characters, so I apologize for that. But there's a limitation in our system. Specifically with RDS, we had some special characters in there that weren't really appreciated, so we skipped those. But it's easier to blame it on CISO. Moving on. Going back to Vault. Rob.
Thank you so much. So we've seen Kerim use Terraform to randomly generate a secret and store it in Vault using Terraform. So now we can see what was empty before. We now have the AWS DB instance secret that is now stored in there. And if we go into it, now we can see the key value pair. So when he mentioned the JSON encode part, this is what we're talking about. So the key being password. And if we reveal the value, we can see that the same, if you've got a photographic memory from the output that Kerim showed you, which unfortunately I'm not blessed with that, you'll see that it matches what we have stored here in the Vault. So I'd say that's a success. So now we can move on to actually consuming these secrets with Terraform. So with our secret data correctly provisioned in Vault, we can switch to the other side and become the consumer. So for this, we're going to provision an RDS database in AWS as an example. So going back to our terminal. So here we're adding a data source for VPC resource. This is just some setup that we're doing initially. And with that data source, the first resource that we need to provision is a security group. We've deliberately omitted some of the arguments that are inside that just for simplicity. but that's what we're declaring there. And next we need a rule that goes for that security group as well. So in this case, it's allow from self. The next thing we need to do is actually provision a data source, which is going to read the secret that Kerim provisioned inside Vault. Okay, so here we have that data source. Like I said, everything's path-based. So it's that secret /AWS_DB_instance. And one thing I should say about the KV secrets engine, if you use version 2 of that secrets engine, the secrets in there itself can be versioned. So we can generate new versions of that secret and specify specific versions that we'd like to reference. So here we just have that data source and we are now ready to use that. So next thing we'll do is actually declare our database instance. And when we do that, one of the things we need to do is declare a password. And obviously this is where it gets a bit tricky to generate a password that meets the complexity requirements, and you need to remember it. So Vault is here to solve this problem for us. Right? So we have the password declared here, and we're using the data source, which we've just declared above, to provision this, this configuration value here. Right, so with that, we can now run a Terraform plan.
Yeah, and so if you paid very close attention, there was a tiny typo in one of the slides. We shortened some of the demo code to use a variable called pass, a resource name called pass, whereas we actually call it AWS DB instance. In the code that we have for you, this actually works, but Hollywood is a little bit different. In any case, we've got all the code that we need. So let's give it a quick test with Terraform plan again. And all of this looks pretty good. What we're seeing now are the exact resources that Drop described. This is unsurprising because the infrastructure as code is expected to work this way. But if you look closely for the AWS instance, you'll see that we're setting the password value. Terraform understands that it's a sensitive value, or specifically the AWS provider for Terraform understands it's a sensitive value. So it doesn't output it to the screen. And if we apply this, we shorten this a little bit because we figured we're short on time. RDS instances usually take 3 to 25 minutes, depending on how much HA setup you've got going or not going. In our case, the last time we ran this took 15 minutes. We wanted to save you that because there's still time to grab a beer later. So with all of this complete, our apply looks good. We added 3 new resources. We added a security group rule, and a DB instance, RDS instance. And we've got an output. So let's scroll down. So what we did in Terraform, we defined an output that's dynamically filled with the data we have. So our instance host name, our port, the user that we defined, and obviously the password. And with that, we have a connection string. If you use MariaDB or MySQL, and you've got the client library locally available, and the client actually, not just the library, you can connect. And this all looks good. Again, this is demo code. MySQL and MariaDB servers actually tell you very helpfully that you should not be using hard-coded passwords on the command line. Should probably use the --P argument, or just use client certificates, which is even cleaner. But the important point here is we can execute a command. We're able to access our database. We can see that it all works. And if we remove all the outputs we have in our code, then you actually have a Terraform setup that's pretty much secretless. So with that, I wager that you know everything you need to know to use the Vault provider for Terraform to write and consume secrets. And to take you a little bit further after this one, here are a few things that we would like to share. First of all, if you all want to see these slides again, you can find them on Speaker Deck. We might have a picture of Rob in there, who is to say. We have a repository that Rob mentioned before, and I did too. This has all the code in there that you need, including provisioning code and consumer code. What else? Oh yeah, we talked about functions a little bit. The Terraform functions page, we showed you JSON code, but there are a large number of other functions that you can make, that you can use, and that can make your Terraform usage a lot better. And then, since we had like roughly 20 minutes today, we couldn't show you all the cool stuff that Vault can do. There's a ton of tutorials we have available. A very interesting one to start with is probably dynamic secrets. But if you ask Rob back, then he'll probably talk about that. And pretty sure we have some more tutorials that can be interesting, but every organization's use case is slightly different. So let us know what you find. And finally, if you have questions and you don't want to ask us, you want to ask the bigger community, you can always check out the Vault forums on discuss.hashicorp.com.